Hey class, just gonna break down 8.2 here in this video. 8.2 is testing the difference between means. It's really similar to 8.1, except you're gonna use the t-test. And the reason for that is because standard deviations are unknown. And that is, what I mean is population standard deviations are unknown. You will have some sample standard deviations, but the population standard deviations are unknown. That's the difference, and then you have to use the t-test with new formulas. Woohoo. Okay, this one, the formulas get a little crazy, so we're not gonna do these by hand. I just highly recommend in this section, just do everything with StatCrunch when you're finding those standardized test statistics. So there they are. I mean, there's the formulas, but it's a formula within a formula, and it's just madness. This one's a little better, but still, let's just do the StatCrunch feature technology for this section. The key that you will have to, the formulas you will have to use are the degrees of freedom. So make note of those. And there's two of them, because you will stop to find critical values. And that's just going to be kind of the old-fashioned way using the table. I thought I would start there, just finding critical values. And then we'll get into the difference between these two formulas and why there are two in a minute. We're going to jump to a problem in the homework and just work on finding critical values for this section. Since they're t distributions, we're going to use these degrees of freedom with the t table. Okay, so let me jump to a homework problem and we'll give it a go. This is 8.2 number 2, if you wanted to pull yours up as well or just follow along here. So this one, all you're doing is finding critical values, and what I have is that HA is that mu1 does not equal to mu2, so that not equal symbol just means it's a two-tailed test. I've got an alpha, and then I've got two n's, right, because there are two samples. And then the first says, find the critical values assuming the population variances are equal. So if you look back on your handout, assume the population variances are equal is that left-hand formula, the one where the degrees of freedom say just add n1 plus n2 and subtract 2. Okay, so I've got n1 plus n2 here. If I add those together, that's 24, and then subtract 2 is 22. That's my degrees of freedom, 22. And then I've got the alpha and 2 tail. So now I'm going to jump to my table with that information. So I'm going to the t table, 2 tail 0.05, going down to df 22. And I'm seeing 2.074. Okay, and remember, if it's a two-tailed test, I would put a plus or minus on that. So let's see if that's right. Plus or minus. You could use this plus or minus here, 2.074. Let's check that out. Okay, and that'll do it. All right, the next one says, find the critical values assuming the population variances are not equal. Okay, that's the right-hand formula where it says population variances are not equal on your handout. That one says do degrees of freedom the smaller of n1 minus 1 and n2 minus 1. So in this problem, the smaller one is 11. And so I'm just going to subtract 1 from that, which is 10. And then go back to my table using the degrees of freedom 10. All right. So if I go to my table here, degrees of freedom 10, and I'm still doing that 2 tail 0.05. Right. So I'm seeing this 2.228. So I can do my little plus minus trick, 2.228. All right, and that's how those work. Now just remember, if the type of test changes, left tail, right tail, or two tail, if it's a left tail, your answer is always going to be negative, even though there's no negatives on here. Just make sure to put one on. And if it's a right tail, it's just what you look up. But those left and right tail, you're going to do the one tail alphas, right? That one right there. Okay. So that's a little background on finding critical values for this section. Otherwise, we're going to jump right in now and run the full test, looking at an example from that handout. So let's go back to that. We're going to be having to jump back and forth here because we're going to be using some StatCrunch, but we'll get it started here. Okay, so this one, we have results of a test and everything's kind of nicely organized in a table. We've got some means, right? Those are your X bars, X bar sub 1, X bar sub 2. These standard deviations, notice they're based off of the sample. So those are S's, right? And then the sample sizes are the N's, okay? And then you have sub 1 and sub 2, all right? And if I look at this problem, I want to find the claim. And then here it is, test the claim that there is a difference in the mean scores, right? So if I'm setting up my steps, a difference would be that mu sub 1 does not equal mu sub 2. That's the claim. And h sub 0 is that they are equal. Okay, so here we have an example of a two-tailed test. When you get to that verification step, you just have to look back here. Right? Here's where the conditions are, or they're also in that summary at the beginning of this packet, right? But you have random, independent, population standard deviations are unknown, and then either the populations are normally distributed or both sample sizes are at least 30. That was the same thing from 8.1. Right? So here we have assume both populations are normally distributed. All right, so we're good with the verification. Okay. Next in our list of steps is typically finding that standardized test statistic, right? So the t-score. And usually that's where you whip out the formula and grind it out. But we are going to use StatCrunch for that, okay? So things to note are all of those, you're gonna have to enter all of that data in. And then also, this is an important statement, the population variances are equal. We'll get to that in a second. That indicates which formula to use, but there's also going to be an indication in your StatCrunch feature for that, okay? So to get that t-score, let's jump to StatCrunch. So I'm going there. Hopefully we can find it somewhere. So you're just gonna open up a blank StatCrunch page and you're gonna go stat. Now this is gonna be a t-stat and it's two sample and it's with summary. So there you are, stat, t-stats, two sample with summary, okay? There's where you go. And looks like we have all that information. So sample 1 is the teacher 1. I got 473. Sample standard deviation 39.7. And sample size is 8. So the other one, 459. 24.5. Sample size is 18. Okay. And then notice here, pool variances. Right? If the populations are equal, you click that. If the population variances are not equal, you don't click it. So here, they're not equal, we're not going to click it. Important to either click or not click to get the right answer on these. So look for that statement about the variances. It's another good indication you're in 8.2 because there is going to be some comment about the variances, which does not happen in any other section in chapter 7 or 8. So that's a good indicator. Okay, jump into the hypothesis test. Just like in 8.1, this is always 0. So just get this inequality right. And for us, it's the not equal, that's the HA. And so there we are, we've got it. I'm just gonna hit compute. And I've got my t-stat. So that t-stat is your standardized test statistic looking like 0.92. All right. I also get a p-value for free. I can make my decisions and conclusions based off of that p-value. if the problem asks for it. So I might want to jot that down. Or you might have to find critical values. It just depends on the problem. So are they doing, what method are they doing, right? Okay, so next let's find some critical values just in case it asks for that. That's when I would jump to my t-table. For this one, the DF, because the variances are not equal, that's when I'm going to do the smaller of the two sample sizes and subtract 1. So this would be DF 7, right? Because the smaller one was 8. And I've got a two-tailed test where the alpha is 0.01. So two-tail 0.01 down to 7. And there it is, 3.499. So my t sub 0 is plus or minus 3.499. Because it's a two-tailed test, I've got to throw that plus minus on there. Okay, now I can go back to the handout and make my decisions and make the final answer. Okay, so at this point we could do the p-value method. I'll just maybe mention that one real quick. I did write that down, the p-value of 0.337. That's bigger than the alpha of 1%. Anytime p is bigger, it's fail to reject h sub 0. Okay, or if you're doing the critical value method, right, there's the negative 3.499, positive 3.499, and then that 0.92 is nowhere near, that's not really good. It should be over there, right? To the right of 0. Okay, but it's nowhere near the shaded regions. So there we go. This is still fail to reject h sub 0. All right. So regardless, whether you're doing p-value method or rejection region method, you're getting fail to reject h sub 0. Right? That's a 0 there. Sloppy too. So let's make that clear. H sub 0. Okay. And h sub a is the claim. We could not reject h sub 0. There is insufficient evidence to support this claim. Okay, and that would be the end of that one. Okay, why don't you give this another one, the second one, a try, and then I'll write it out, and we'll see if you get it. So I would pause the video now, give it a go, and then I'm just gonna have the answer appear here, and we'll talk about it. Okay, here is what I would have in StatCrunch under the 2 sample t summary. I got my sample statistics in there. I clicked pull variances, highly important because the variances are equal on this one. And then I'm got the greater than, make sure that's just stays 0, and then a greater than because that matches my HA. And then I click compute, and then I get my t-stat of 3.26 and my p-value of 0.001. Okay, so now I can go back to my handout and this is what you would want, right? So there's your HO and HA based off of the claims. It's a right-tailed test. I've got my T and my P. I'm just going to use the p-value method on this one. P is less than alpha of 5%. Anytime P is smaller, reject H sub 0. If you reject H sub 0 when HA is the claim, there's your final conclusion. Okay. This one you can't really do the critical value method because it's off the charts if I tried to use the chart, so I would just go with p-value there. Okay, that's it for now. Hope all is well with you. Shoot questions my way. Thanks.